So good afternoon, everyone. Welcome to this EFB webinar. This webinar will be recorded, so please turn off your camera if you don't want to be seen. Please stay muted. And if you have any questions, please use the chat to type your questions. Today's topic is about design, implementation, and maintenance of green facades with climbing plants. I'm very honored that we have Marco Schmidt, Barter, and Erwin Zeisel as a speaker here today. Let's start what we do within the next one and a half hours. I will do a slight introduction. Then we have the presentations of Marco Schmidt, Guy Barter, and Erwin Zeisel. Then we will have additional discussion and Q&A session. So if you have any questions, please prepare them already in the chat. And in the end, we make a conclusion, and you will see what's next and what upcoming events we are offering at the EFB. First, I want to say a big thanks to our sponsors. We have Karlstahl Architecture, who is very active and system provider of climbing trellis. They offering the green cable. They have different types like the green cable light, green cable heavy, and green cable safety. They go from modular systems for small and medium-sized areas up to bracket systems for great heights and facades with external thermal insulation composite systems. So it's suitable for plants with high dead weight. And the green cable safety suits for car parks, office, residential building, where you can have fall protection and greenery in one. So if you're interested in their work, please contact Andreas or Kun. A short introduction about the EFB, the European Federation of Green Roof and Living Wall Associations. We are an umbrella network founded in 1997 as a non-profit organization and counting currently 18 national associations coming from 20 countries all over Europe. And we have extended networks with the World Green Infrastructure Network, ELCA, IFLA, So Green, and so on, in order to make European cities greener. And today we will hear from Marco Schmidt. He's a researcher from the Technical University of Berlin about some research and what climbing plants can do with our environment and what benefits we can have. He's from the Constructive Design and Climate Adaptive Architecture Department and from Germany. Guy Barter, who is the chief horticulturist of the Royal Horticultural Society, and his colleagues are describing him as a walking encyclopedia. So we are very looking forward to his knowledge he's going to share with us about climbing plants, and he's from the UK. And then we have Erwin Zeisel. He's a designer and architect based in Austria of the office Rataplan, who will introduce us some best practice examples using climbing plants. So I will leave the floor now to Marco. You can share now your screen, please, Marco.
Yes, Elisabeth, thanks a lot. I hope my screen is now available. Yeah.
Yes.
I'm working, so I started with Manfred Köhler in the 80s in Berlin. I was implemented in one of his research projects in one of the first projects mid 80s in Berlin-Kreuzberg, so a high dense area. I'm also since 10 years working in a Federal Research Institute. It's a Federal Institute for Research on Building, Urban Affairs and Spatial Development. We are part of the Construction Ministry, and the institute is a research group on all public federal buildings we have in Berlin. So guidelines for sustainable construction are one of our main publications. You can download quite a lot on our website for free as well in German and in English language. And yeah, first to the problem. We are starting now, it's getting hotter in urban areas. Um, Fortunately, after half a year of really dark and a wet season, and it's getting hotter and it's getting drier at the same time, and both is interconnected. Because if you look at the global energy budget, this is the incoming radiation on 1 square meter worldwide. On a globe, nearly 50% is converted into the evaporation of water. We have three other components. It's the increased thermal radiation. This is related to the surface temperature of the Earth compared to the surface temperature of the atmosphere, mainly depending on, for example, the color. We have a reflection, that's what you can see on the surface, and sensible heat. Yeah, sensible heat is convection at the same time. So it's hot air then released into the atmosphere. I would say this is the main data you find at Wikipedia and other publications from NASA. If you look now what is going on in urban areas, if you convert all the incoming precipitation not into latent heat, into the evaporation of water, because you shift rainwater into sewer systems, then you have no chance of that it converts into cooling. And this is my own measurement on an asphalt roof in Berlin. So there's no chance other than in the summertime that you convert incoming shortwave radiation into increased thermal radiation and into sensible heat. This is hot air. And this you can measure. That's why it's hotter in urban areas. And the explanation is quite clear. What we need is the evaporation of water. This is missing in urban areas because vegetation is missing. And we have a huge problem worldwide because urbanization rates are about 150 square kilometers daily. Yeah, so it's a little bit less than the size of Vienna. So every day, mean city is created worldwide. So urbanization is increasing. And additionally, we lose about 350 square kilometers of forest daily. And the desertification rate is about 300 square kilometers. That's about the size of Hamburg or Berlin, what we lose in vegetation every day. So we convert the global energy budget left upper to the right lower side by 800 square kilometers every day. And then we wonder why it's getting hotter and drier. And of course, this is completely interrelated. So in my view, the global warming is the same topic like the urban heat island effect because we lose vegetation. And I'm not really a fan of these carbon discussions. So in my view, we have to focus on the topic of vegetation, water, and soils. Because if you don't evaporate 1 cubic meter of water, then you get less, about 3 to 5 cubic meters of precipitation. It's related to the so-called small water cycle. If you measure where the precipitation is coming from in Vienna or other cities, it's not from the Atlantic Ocean. It's mainly evaporated water already in our areas from Spain, from France, from Portugal, or in the neighborhood. This we call the small water cycle. It's important to understand that about 2/3 on a global scale is coming from the small water cycle and just 1/3 from the precipitation from the large water cycle. So I started in the year 2020 to evaluate the Institute of Physics from Humboldt University. So it's a different university here in Berlin. And here we use the rainwater to supply adiabatic cooling in air conditioners. And we irrigate 450 climbing plants to produce shadow and evaporative cooling. And evaporative cooling, that's a difference to a normal sun protection system. A normal sun protection system won't evaporate water and therefore won't provide real cooling on site. Main goal was the reduction of operating costs. And here, for example, in the south-orientated facade, we have 72 planter boxes for the whole building, all in all 150 planter boxes for 300 climbing plants, and 150 climbing plants are growing directly out of the ground. And I'm now carrying out the scientific monitoring since more than 20 years. We supply the plants with the harvested rainwater from the roofs. The roofs are mainly not greened. We harvest the rainwater from 4,600 square meters. That represents about 2,600 cubic meters in 5 tanks. We have a total volume in the tanks of 40 cubic meters. That's quite normal that you just use 2 to 5% of the annual precipitation to harvest the rainwater. The main goal is that you get an autarky of about 60 to 70% and that you harvest as well 60 or 70% of the runoff. So there's additionally tap water supply in one of the tanks inside of the building. Stormwater is carried out. We pump the water then in a small pond in one of the courtyards. So the whole building is completely disconnected to any sewer. And that's how it looks in summer times. So this is the Aristolochia on the left side. On the right side, wine, vitis. And we are using about 20 different species. We have as well a real wine, so a little bit like urban farming. I have the keys, so in the summertime and autumn, I go there and harvest the wine. So not many people have directly access on the planter boxes outside. These are the planter boxes. Important is that you have to define how you irrigate, because you cannot measure the real water content in the soil. I carried out, I defined a small water layer inside of these planter boxes with expanded clay of 10 centimeters and then a fleece and then 3 types of substrate in the planter boxes, and the plants might grow there where they find water or where they find the best conditions for water, and we supply as well fertilizer directly into the water. When the water level sinks of about 0.1 millimeter, there's a small switch here inside, and then it's a small control system. The small control system can then switch on the valve and for irrigation of about 10 liters. And then after 40 seconds, I stop this small system. So it's an interconnected from each planter box to the next one, and therefore it's quite easy, for example, to irrigate 10 or 15 planter boxes just by one valve. And this is quite cheap and easy if you compare that to other systems. Another option would be that you over irrigate. For example, you give 3 times more water here on top of the soil, but then you have to harvest the water back into the tanks. And this is much more complicated because then you have to find a way for the pipes back into the rainwater harvesting system. That's what we are doing in Hamburg in the Bunker St. Pauli project. There we over irrigate. So in total about 8 to 9 millimeters per day. And then we harvest water again in a big tank of 350 cubic meters of storage capacity. And now here in this case, by evaporation of water and irrigation exactly, I can really find out between of 2 months what is the real evaporation rate of the plants. It's just because exactly I can irrigate, and so for example at night there's no evaporation rate going on, but during day the plants, the leaves starting to evaporate depending on the climate conditions. If you're in a courtyard, then you have different radiation rates and different potential evapotranspiration. So therefore, in the south-orientated facade with most of the incoming radiation, we get an evaporative cooling of 280 kilowatt hours per day per facade. That represents about 440 liters per day. The operating costs. So normal, if you have a constructor sitting at the table, they always argue, oh, it's so expensive. We have to care about the plants. We have to irrigate them, fertilize them, care and cut and replant. If you compare now the operating costs for the plants to a conventional sunblinds, then you can save more than 90% of the costs. In this case, I would say this is too cheap. Yeah. So the first thing Humboldt University tries to save is money for the maintenance for the plants, but it's a big mistake. If something happens here for the conventional sunblinds, they don't open or they don't close anymore. You have to go there, climb up and exchange, for example, the motor. And this is much, much more expensive. So these are now the mean costs in between of 3 years for Humboldt University for the maintenance of the conventional sunblinds compared to the operating costs and maintenance for the plants. So it's cheaper in investment and cheaper in operation. And it has a better performance for the building. If you compare the costs for heating and cooling for this building, then unfortunately these the first 3 column groups are when you start building and you simulate the energy budget you need for heating and cooling without sunblinds, with conventional sunblinds, conventional stored, or with automatic controlled sun blinds. And these 4 and 5 are now the results from my own measurements, and in this case it fits quite well. The measured data with the simulation, because on site we have automatic controlled sun blinds for half of the building, and half of the building has now green facade. And here you can recognize that you can save lots of energy inside for cooling, especially. So nearly 50%. You increase a little bit for heating overall, because you cannot control it like you open or close conventional sun blinds. So you increase a little bit for heating, but you decrease for cooling. So in total, you can save lots of energy for the building. And another effect is because we provide evaporative cooling. Now, if you measure the surface temperature of the building skin behind conventional sun blinds and behind the green facade, then you save additionally costs, because it's type of long wave emission from the skin, from the surface here, from the glass. That is, of course, transmitted. It's a transmission inside of the building from the glass. There's no way out. And if you define, it's a goal of 26 degree. We want to keep our buildings of 26 degree in the summertime by definition inside of the building. Behind the plants, the glass temperature is 27 during the day, and behind the conventional blind, it's 34. That is the same like the urban heat island effect. If you don't evaporate water, you have to convert all incoming radiation in long wave emission and in sensible heat. There's no way out. Here you can see that the conventional sun blinds will close, then they might open because of higher wind speed in between. Here they close again, and here they open. So it's 8 times more long wave emissions behind conventional sun blinds than behind the plants. So you have high benefit for the building. So just a view, because I have to finish after Elisabeth gave me 15 minutes for presentation. This is one of the projects currently in Hamburg. It's DESI, Deutsche Elektronensynchrotron. They have huge heat wave inside, lots of electricity inside of the building. So they use lots of electricity, and therefore they defined that they started to green this building now with climbing plants. Another project, quite famous meanwhile, it has won the Landscape Architectural Award and as well the MISIM Award in Cannes for sustainable construction. It's the Bunker St. Pauli in Hamburg. I would like to invite you. So in 2 weeks, I have guided tour. I will carry out a guided tour on site at Saturday. And this is directly, it's not a simulation, it's a real picture. So people are coming on top. It's a free entrance. You can walk around the old bunker until the height of 60 meters. It was quite expensive. It was more expensive than it was planned at the beginning. So they started with 25 million of investment costs. Now the investor was confronted with 120 million euros. That's why he became a little bit upset. But this project has won lots of architectural awards meanwhile. So I would say it's the best investment he ever did, because nobody knows where the money will disappear in inflation in the next years. So I would say it makes sense. And now one project, it's the following project after Institute of Physics Adlershof. I'm part of the planning team as well here. It's a zero emission office building of Hafen City in Hamburg. Architects are Heinle Wischer, and they're starting now with the construction at the moment. And I carry on with some experiments for plants because south-orientated facade is completely dominated by photovoltaic panels. So here we concentrate with the vegetation on east, west, and north orientated. It's a little bit difficult for our climbing plants idea. So thank you very much for your attention. This is Hundertwasser. I would say he was really great in the past. He designed Bunker St. Pauli first of all. Yeah, he just received a picture and then he started to draw for the Hamburger Abendblatt 1992 when I wrote my master thesis on green roofs and impact on the urban climate. And this topic I follow, and we follow him as well with his ideas. He made really great projects. I would be glad to evaluate them. I have to concentrate on just a few projects which I may evaluate now. So I just showed you one of them. Thank you very much for your attention.
Thank you very much, Marco, for this very interesting insights about some research projects. We have already some questions in the chat, but we will come to it in the Q&A session later. Now I'm asking Guy Barter to share his screen, please, to hear more about some climbing species. And yeah, the floor is yours.
Thank you. Hello, I'm Guy Barter. I hope everyone can hear me and see my screen.
Yes.
I shall call that a yes. I work for the Royal Horticultural Society. It's the world's oldest and most famous horticultural society. That's what we say anyway. And I've been working there for some considerable time, and all the things that Marco talked about so ably just now are things that we're very, very concerned about as well. And we're a charitable organisation, and we do try and do good works. And one of the things is researching to make cities greener, and that includes green walls. Green facades are something that we've had for a very long time, and they're something that's traditional. They've always been done. It's part of the long-term sort of thing, and I hope that we're all talking about the same thing here. What Marco said gave me considerable confidence, so I think we're all right. There's a lot of ways of doing a green facade. One is to let plants grow, other is to train them. There's a lot of skill that has been lost or neglected over the years in making green facades. One of the first people to write about the ecology of climbing plants was a certain Charles Darwin. You may have heard of him. He was actually a member of the Royal Horticultural Society in its very early days. And his book is still in our library, and it's a much read resource. Climbing plants are terrible cheats, really. They scramble over other plants, take advantage of plants that work much harder. And because of this, they're always going up to the light. And that's all very well. But if you want a green facade, you really don't want one that's all up round your guttering and your roofs. You want something that covers the walls reasonably well. And some plants do this much better than others. Clematis, for example, and honeysuckle are classic cases where it soon gets bare at the base and you've got a lot of plant higher up where it's hard to maintain. They're fantastically good at gripping walls. In Britain, we look askance at climbers because of cost of property is so high, the cost of and hiring of builders is so high, so people tend to avoid anything that might cause damage that's going to be costly later, and that's one of the barriers. One of the things that we find in Britain, at any rate, is our houses are quite small. People like to live in houses. They don't like flats. And as a result, people build over their gardens, putting up extensions and storage sheds. And the gardens get smaller, so the greenery decreases. But they could, with encouragement, counter this by growing plants over the various structures in their garden. Ideally, you want plants that don't entirely grow to the light. I mean, negative phototropism, as it's called, is something that roots do. You won't find roots coming up into the light very often. And we also want plants that head into the dark. Some plants, like ivy, head into the dark at the drop of a hat. And in my garden shed, for example, it's absolutely crammed with ivy that's grown in there and is very pale and etiolated, and I have to cut it off. I think it's very impressive the way plants can cling and go in and find these gaps. You see an ivy-covered wall, that's heterohelix. It's amazing how it fills up all the cracks and crannies, and even dull areas that you think the plant might miss are covered. Happily, climbing plants pretty much grow themselves given half a chance, and they don't need a lot of feeding or a lot of watering if they're growing in natural soil. And it's traditional to grow these climbing plants in natural soil, because you're making a considerable difficulty for yourself if you try and grow them in pots, because climbing plants are essentially fantastic wicks. They suck the water out of the ground. And if you've only got a limited amount of ground, as in a pot, then you have to do all the amazingly technical and clever things that Marco did with his plants. But we always feel that putting them in natural soil would be best if you possibly can. The trouble is, of course, that in urban areas, the natural soil is usually scraped off and utterly destroyed by the builders. And so you have to import soil, or you have to improve the soil that's already there. And that can be expensive and a difficulty. There are companies that specialize in producing soils, manufacturing soils. These are usually a not entirely satisfactory mixture of quarry overburden and composted municipal waste. So it's always better to use a natural soil if you can possibly get hold of it. Irrigation shouldn't be required to the same extent that you might think, because these plants normally they have to fight and struggle in the forest or in the mountains, and there's not a lot of water, and they have to fight trees and other plants for it. So they're usually reasonably water efficient compared to some other plants like trees, for example. The pest and diseases situation, in my experience, there's very little that get to go wrong with them, and if there is, there's not a lot you can do about it, because if a tree is if a plant is 10 meters up in the air and it develops a fungal leaf spot, then you pretty well have got to put up with it. In Britain, at any rate, aerial applications, whether by aircraft or drone, are no longer approved. But you can use a drone, for example, to apply a foliar feed or biological control. So as drone technology becomes more available, you have more control and greater ability to intervene in your green facade. It's a truism, I'm afraid, that any green installation, whether in a commercial or a domestic building, has to be looked after. And there's a dire shortage of people who are able to and willing to do the work that's required to maintain plants. And that's because the occupation or career is not well paid, and it's usually better money to be made in other things like landscape contracting, building new landscapes. So maintenance is always an issue, and it's made more difficult by the height of green facades. There are health and safety regulations, so that the gentleman you see here on a ladder and would no longer be permitted to do that at Royal Horticultural Society gardens. He would have to, and quite rightly, have to use a cherry picker, a safer machine, and there would have to be some risk assessments. So, but not everyone's got access to cherry pickers, and they're expensive, and training is needed. So these have to be things that have to be considered at the outset. And every so often, quite serious maintenance has to be done, and that has to be factored in. Maybe after 20 years, the whole thing will have to be redone. The supports that are put in nowadays, made of stainless steel, as indeed our sponsors mentioned, seem to me to be very good. And I haven't had any experience of using them, but they seem to have taken into account all the things that one might expect, like the corrosion and whether they would do damage to modern surfaces with insulated walls. But they seem pretty good. But it's a truism that you cannot have a green facade without also having some maintenance. Ivy is one of the commonest plants. It's evergreen, and it attaches by adhesive roots. If you've ever tried to remove ivy from a wall, you'll know that those adhesive roots are fantastically resilient, and nothing short of a wire brush will shift them. So you often see buildings covered with ivy. Ivy has a kind of love-hate relationship with the public, and indeed with property owners. The research suggests that it won't cause damage to sound structures as long as there's sound masonry, but it has to be sound. You can no good trying to grow a green wall over an unsound surface, or if difficulties will follow. It's a pretty fast grower. There's lots of different kinds. And the research that my colleague Tiana Blanus has done, that we'll come to at the end of the presentation, she used two kinds, but there's many hundreds of different forms of ivy. So it is a plant that's well worth looking at. It's not that hardy. I didn't really think about hardiness of plants, because I was thinking in an Atlantic Europe context, but of course other climates exist. And I was interested to see that ivy, for example, won't grow properly in Finland, apparently. So that has to be borne in mind. Strongly negative phototropic, it gets into all sorts of nooks and crannies. You don't want it getting into your roof. That's another aspect of maintenance. Every so often, someone has to go up and trim that to keep it down. The lifespan is remarkably long. There's very old stands of ivy, and as it gets older, a strange thing happens. To those of you who are not botanically minded, you may not be aware that the ivy leaves in the picture you see there are the juvenile form, and it produces an adult form later on with rounded leaves and a great deal of berries. And those berries are not much relished by birds. They leave them to the last bit of the winter, so they're a good late winter source of food. And as RHS research discovered, the ivy-covered walls are also rich in invertebrates, and invertebrates are the building blocks of urban ecology. Its biodiversity value is therefore high, at least in Britain. Parthenocissus tribe are fantastic climbers, vigorous and invasive. They have to be careful in some regions. You need to check with the local authorities. The sticky discs at the end of the tendrils, not all of them have sticky discs. Some twine and twist and need the wire supports, but some of them have sticky discs. They can apparently support about 260 times the weight of the plant. So that is quite remarkable. These are deciduous, which presumably reduces their effect in the winter. But they grow very big, and there's some magnificent examples to be seen. They're quite quick, 5 to 10 years to their ultimate height. No one's going to worry about that. They're reasonably hardy. There's the other one, the Virginia creeper, which is Parthenocissus quinquifolia. The RHS says it's hardy to -20, but I've seen pictures of it growing in Toronto in Canada, where it gets a lot colder than -20, terrifyingly. You have to be careful where children and pets are concerned, because some climbers harmful. But having said that, in years of giving advice to the public, hardly anyone has come to harm from plants. So although one has to be aware of it and to be cautious about it, it's not as big a deal as some people might think. Another good long-lived climber. Wisteria is one of the favorite climbers and can roam huge amounts. Ideally, it needs a bit of annual pruning. Typically, you cut it back in the summer to restrict its growth and then cut it back in the winter so that the flowers can be seen. But that's not at all essential. You often find wisteria growing up into tall trees, 20-meter trees even, and they do grow very remarkable. Another long-lived climber, a deciduous one. It has flowers. The flowers are often followed by large quantities of seeds, but the seeds are of no particular value as far as I know. But the flowers are exceptionally beautiful. One thing you have to bear in mind with climbers is when you do need to cut them back, and wisteria is one that sometimes needs cutting back, is that a sudden shock to the photosynthetic apparatus can leave them vulnerable to one of the only diseases that I've found that climbers are seriously susceptible to, which is honey fungus. I mean, presumably, like all plants, the climbers secrete sugars, and the sugars support microorganisms around the roots, and the microorganisms confer protection on the plant from the honey fungus pathogen. And if you cut back the foliage too severely, then you'll leave the plant vulnerable to honey fungus. So it's as well to have a schedule of maintenance and not do anything too drastic too often. Wisteria is one of those plants that is not particularly negatively phototropic, but it does get behind pipes and guttering and that sort of thing. And then the trunks swell, and then it can be difficult to maintain. It can do damage. The Russian vine doesn't actually come from European Russia, it comes from Central Asia. And if you're living in a really cold region, like Canada or Finland, presumably, then this vine is extraordinarily hardy, cold hardy. And that's something to bear in mind for regions that are particularly difficult. Apparently, it's not invasive, but if you travel around London, you often find it is spreading into the railway tracks, the vegetation along the railway tracks. So I'm not sure how long the non-invasive situation can remain. It's the kind of plant that will grow up a telegraph pole and then follow the wires across the road and into the buildings and houses across nearby. So it really is fantastically vigorous. And that, of course, poses a maintenance problem, is that you're going to have a lot of plant going in the wrong place. But when a site is difficult and growth is restricted, that's the kind of climber you want. Marco mentions that grapevines are one of his favourite climbers for obvious reasons. We find, certainly in the British climate, that grapevines are absolutely prone to a downy and a powdery mildew, and a real problem with disease. Its cousin, Vitis cognetii, is a more vigorous plant, and we don't find the same disease problems. And it's a handsome plant with marvelous autumn colour, a bit like the Virginia creepers and the Boston ivy mentioned earlier. It's a long-lived plant, and one that's been widely used. And I think it's worth thinking about, if you do want a fruiting vine, one of the things that can grow and may grow more as under climate change is actinidias, kiwi fruits. They really are rather frost sensitive, but with the changing climate, there may be something that will be feasible in future. I've seen some very large examples on buildings in mild regions. This is one that Tiana used for her research. There's a similar plant, Hydrangea petiolaris, which is a better plant in my view. and that's very widely used for covering walls. That one, unlike this hydrangea vibernoides, which are twines, the hydrangea petiolaris grips the wall with little aerial roots, and is well worth considering. They tend to be slow to get started, but when they get going, they're fairly good plants. Trachilospermum, or star jasmine, tends to be rather on the tender side. Another one that was favoured by climate change, as the winters are no longer quite as cold. And it's a flowering one, evergreen. There's not so many evergreen climbers, and it's unclear why that would be. I think it's probably because most climbers need to do their growing in the sun, so they scramble up trees to get to the sun, but the evergreen ones presumably do most of their growing in deciduous forests when the leaves are off the trees, which is a valuable attribute. This is a plant that we wouldn't grow 20, 30 years ago, but now it was just too cold in the winter, but now it's much more widely grown. It's worth thinking also about the building has a north, south, a west, and an east face, obviously. And in Atlantic Europe, you don't really have to worry too much about the south face because it just doesn't get hot enough. But in other climates, of course, you have to be quite careful. And there you may often find that the green facade is on the north or west-facing walls. There are climbers that do particularly well, like the Trachilospermum or Actinidia on the south-facing wall and ivy on the north-facing wall. So that's something that has to be borne in mind. That's aspect. Many climbers grow in forests, and so they are vulnerable to high winds. But the ones that I've mentioned here are pretty good on that score. It's worth remembering, of course, that it's worth planting a diversity of plants because we live in a globalized world, although Mr. Trump may see to that. And where you have a global economy, you have global pests and diseases. So if you plant only, say, ivy, for example, and a disease is imported, like the box tree caterpillar that has damaged box trees, or ash dieback that is currently laying waste ash trees all over Britain, you're in a serious problem. Fortunately, there's lots of diversity to choose from. The Hilliers Trees and Shrub Manual, which is published was published by the Hilliers Arboretum in Britain. The Royal Horticultural Society publishes it now. Lists 162 species of hardy climbers that grow in Atlantic Europe. On the RHS website, there's a little free service called Find a Plant, and you can ask that to find plants that suit your needs. So when I asked it to find climbers and wall shrubs, it doesn't differentiate the two, unfortunately. There are nearly 600 modest climbers and shrubs and 54 enormous climbers. I don't think there's many shrubs get to 12 meters, and nearly 400 intermediate size. I have to take that with a slight pinch of salt because it also includes synonyms. That's the same name, different names for the same plant. So there does seem to be quite a lot of diversity to look at. Inevitably, when a market forms, like for green facade plants, in the same way that markets have formed for drought-resistant plants, for people like Pierre Dudolph and his self-sustaining herbaceous plantings, better selections will be discovered. People will go plant hunting to find, let's say, hardier climbers for use in northern countries, and then breeders perhaps will start making crosses and try and get better plants. I don't think that has started yet, but that's certainly the normal course of events. That's something to look forward to. Unfortunately, although you can breed an annual in less than 10 years, it can take 25 years to breed a woody perennial. So that might take a little doing, but it'll be interesting to see how that develops.
I just have to mention the time.
The time. Oh no!
Yes.
I'm in trouble. I'll be quick. It's the RHS research. And what Tiana did was she built little houses. You can see all this little field of houses at the University of Reading. She works for the Royal Horticultural Society, but we make her go and work in Reading, which is not that far away. And she builds little houses. There's a heater inside them, and then she grows. Well, she and her research students grew climbers up them. And then one of the researchers I was mentioning earlier was the invertebrate abundance, which we found to be high. Our entomology team worked with Tiana on this, and we also looked at the insulation values, which are pretty much, as Marco was saying, climbers insulate well in the summer, keep the heat out, and in the winter to retain heat. And then there's also research that Tiana has done. Climbers get everywhere, and you don't want them being a nuisance. So we've done research on how to stop them, and various anti-vandal paint, which is very slippery, and sheets of potentially harmful metal like copper were found to retain them. And so thank you, and apologies for overrunning.
No, thank you very much. I mean, there are plenty of species out there of different climbers. So thank you very much for this insight. Yeah, I now leave the floor to Erwin and ask him to share his screen, and we will see some projects from the designing perspective. Thank you, Guy.
Okay, I will try to keep it as fast as possible because we are also a little bit on time pressure now. Okay, in the upcoming sheets, I will show a few examples of expertise, what we gained in the last decade. It started about, I think now 10 years ago, where we had our first project of a green facade. That's this one here, what you see a little bit in the image already. And through all this period of time, we recognized, start the project in certain step-by-step strategy. And at first, we always clarify the framework conditions of a project, like also ownership structures, because it can be also quite different. And the regulation, what could come up. The building structure and space requirements, and also the structural analysis of the building height. From the architectural point of view, of course, we are always interested in the aesthetical approach of the existing building, and we try to find a design solution what can fit with it. We think about the technical and vegetation technical planning, and so also in orientation terms like sun, shade, and wind conditions, and the building structure itself. The selection of the plants, of course, and self-climbing plants, or if it is a trellis climber, fruit shrubs, flowers, grasses, and herbs. Depending on the plant choice, we decide which design the climbing structure should look like and how it should work. The trogs and facade greening elements, the irrigation system and the drain system, etc. And we do it, of course, for the benefit, what we can get out of a green facade in the impact of our urban surrounding, the improvement of our microclimate and reduction of the temperature peaks on the surface of the exterior walls. and the reduction of up to 20% of the transmission heat loss. And of course, reduction of dust in the air, etc. There are additional aspects to consider. Of course, the structure can be used to climb on it or in the risk of vandalism, rainwater drainage, and system separation in the water supply in terms of grey water. The insulation of the planters, the accessibility of the maintenance operations. Then, of course, fire protection and growth restrictions, what is mainly exists in Vienna. The approvals and also on the view when we, for example, use the sidewalk for our construction. Because mainly on the street side that we need to use it. And so I show you 3 examples, a C project what we done in the last decade. Started with the first one where we gained our first experiences in green facades. It was a building for the waterworks in Vienna, built in the 60s with a strong vertical facade structure, southwest oriented. And the goal was to renovate it in terms of thermal isolation and combine it with a new green function or structure. In order to make the design for a shading structure, what we were asked for, we had to analyze the shadow patterns of the existing building at different times in the year. This gave us a result in a solution that largely prevented the rhythm of the relief formed by the pillars and parapets and windows. Staggered strokes arranged across the 2 window bays, creating a new pattern in the combination with the existing vertical structure. We used different type of plants, Dutchman pipes, honeysuckle and wisteria, blue rain. And the position. The stroke itself was also, of course, a very technical approach. And here you see the build-up of one of these strokes with all its necessary layers. So the plants could work well in it. You see the preparation of the strokes before they were mounted on the facade. No? So they were pre-prepared. And one of these strokes with the plants and the soil inside had about 800 kilograms what needed to be lifted. The irrigation concept included 5 separate water cycles. You can say every floor had its own water cycle to keep the water supply from each stroke quite consistent. What mainly worked well, just maybe on the right side we had a little bit less. So even so, the system was not right dimensioned. So it looked like one of these on the left-hand side, one of these exit points in the facade for the water supply. And on the right-hand side, you can say you see the water supply management part, what was positioned in the roof. Here you see an example, image of the final result of the facade. And on the right-hand side, you see that there the plants are less growing because the supply was. Yeah. What was interesting for us that from this point of view, from an angel view, you had more dense greenery, and from the front you had, you can say, more decent type of green, so that the people from the inside could easily look through the window still outside and had enough light. What was important for an office building. Some more images. The trellises were designed in waveforms to implement, of course, the building's function as the waterworks. Some more images of this one. The second project is in the first district. It's called the Zierlitzhalle. It is an electric substation, also built in the 60s. And the idea was to create a network of plants to cool the environment and help prevent our urban heat islands. The trellis structure with two different spaced structures crossing each other are symbolized a network pattern, refining the tension, what is behind maybe electricity. The tall metal trucks emphasizes the growth, reaching up to about 20 meters in height, and provides sufficient root space for various types of wisteria. Here you see the builder on the right side of one of these strokes, and also the foundation of it, what was designed like bridges so that external cable and pipe routes were possible, because on street sides you have a lot of installations. To withstand the strength of the plant, what is unfortunately quite strong, it couldn't get and can also destroy the structure what we construct, and the windows, we used steel pipes and not cables in this case. Some images of this one. I think this photo was after 2 years after installation, so it grew quite fast. The last one is a research project what we worked on, and it is about a research project called Glasgrün, where vertical green solutions are being developed for buildings with glass facades in collaboration with partners Emprise and Liva. These systems are intended for use in existing structures and large scale glass facades. In the food retail section, because they had the problem that they had a lot of overheating in the summers, and so their fruits were not sellable after a short time. The area on the southeast and the northwest side of the Emprise branch are proposed for shading due to summer overheat. Caused by intense sunlight. Additionally, the existing free soil area in this area, because of course we are here on the countryside, so it is much better than in the middle of the city, we could use in reality the ground, so we didn't need it to make trucks. Based on the central organized technical infrastructure of the roof. We could also use the water supply pipes on the roof edges. The trellis structure are connected on the flat roof and on the ground, and this absorbs also the wind loads. So it is connected on the top and on the bottom. In this case, it was the idea that since the full coverage of the vegetation will need at least 3 growing seasons, the design of the trog and the climbing structure should be made appealing and somehow nice, even without plants. The development of the trellis system was carried out by using parametric design, allowing local conditions to be precisely defined, like height, depth, and dimensions. In this case, we used pipevine and common hops, roundleaf bittersweet, and other climbers who are winding their way along the curves of the steel mesh and in between, creating a playful woven structure. It serves simultaneously as habitat and sunshade, and even as artwork. Thank you very much for your time. My colleague went, so we and he is in reality our mastermind behind these green facades. So in case when there are some questions are coming and I can't answer them, we are happy when we can answer them by email too. Thank you very much.
Thank you very much, Erwin. I'm familiar with some of these projects, so they are growing really nice. And yeah, we will now have some time for some Q&A. If I've seen there were some comments in the chat. So sorry. There are some questions about the presentation of Marco, if we are able to share his presentation, and maybe we can use it or save it and send it out to the participants, if that's okay. Yeah, there's from Peter Küsteres, we have a question about the Hamburger Bunker. He assumes that this water is also fertilized before it will return into the tanks. And how do you control the salt content? And all mineral fertilizers leave some kind of salts in the surplus and recycled water. What do you do against germs and so on?
Yeah, I may answer that. I already answered now in the chat. We are not using any filters. I think that's not necessary because if you implement filters in a rainwater system, then you need to maintain them. Yeah, you really need to control and you need to clean them. There would be an option to measure maybe the conductivity. So we carry out measurements in conductivity once in 2 weeks. in a laboratory together with the pesticide. Yeah, we have the herbicide in the sealing membrane, unfortunately, at Bunker St. Pauli, like in other projects. So as an architect, you always have to be careful where you harvest the rainwater when it gets in contact with building material where pesticides are mixed in. So that's a problem. We use less fertilizer because I know you can increase the concentration. I calculated, currently we irrigate 32 cubic meters per day, and then you need 32 kilogram. No, I think more. No, it's 32 kilogram by definition of fertilizer. We're using much less, so just 1/3. And therefore, if you irrigate the same water 3 times, then it would fit. It's important that you really measure the amount of rainwater you use in which floor. So I measured for one floor 26 millimeters per day, and in the upper floor just 3.9. So in total, the 30 cubic meters would fit. But if you look at the distribution on each floor, then you really have a problem. So therefore, always if you start with an irrigation system, you need monitoring. Yeah, you can just make it automatically, just to get the water sensor directly connected at the control system, and that you check that everything is working. I think that is really important. Yeah, and we insulate the pots always. Not at St. Pauli, because there we have 60 centimeters of soil up to 1 meter and on the whole area. Then you don't need any insulation, but at Adlershof we insulate the pots. I think it's important just to understand why. In the winter time, our Wisteria sinensis, they die in the planter boxes, which are not insulated, because there the temperature drops below -7 degrees. If you insulate a planter box, then the water has first to be converted into ice. And if you insulate that, this time takes about 2 to 3 weeks compared to non-insulated boxes. So therefore insulation, in my view, is necessary. Except maybe the system from GKR Hydro in Munich. I'm not sure about that, yeah, because their evaporation condensation is important inside of the boxes. If you insulate them, then evaporation will take place less. That's for all.
Okay, and how do you maintain the climbers at the TU Adlershof?
Yeah, they are not really maintained. That's a problem. Yeah, I would say you need at least twice the amount I announced. They just leave it like it is, and they are not qualified, this company who is responsible for it. We have to change it now. It's really a pity, yeah, because I cared now 20 years for the whole system, and I started to replant, try this plant, another type, and so on. And now last year they stopped irrigation completely, yeah, because I don't know why. Yeah, they don't care about anything anymore. I hope they will sweat this year and then next year replant.
Okay, so it's not the people who are working or having their workspace inside who are cutting
No.
through the climbers to get, I don't know, some view outside. So it's left all by themselves.
You need maintenance. I think it's important. Yeah, you have to define it already in the planning process. But the maintenance is much, much cheaper than the conventional system. That's why we try at our scientific institute from the Federal Construction Ministry, a low-tech strategy, yeah, because high-tech is failing. Yeah, we have much too much ventilation systems, compression cooled systems in our buildings, and these systems, they fail. It's not the vegetation that fails. The vegetation is much cheaper and it performs better. Yeah. But at the moment, I think it's an interesting discussion. Why? So it's cheaper in investment, cheaper in operation. It's better for the building and better for the environment. Now we have to ask why the architects always try to implement conventional sun blinds. I think especially in Germany, but in other countries as well, it's a question of losing control. They don't want to lose control, and therefore you implement lots of valves, lots of ventilation system. You want to control even the CO2 amount in the building. It's completely bullshit because you end in buildings which are too complicated. You cannot maintain them maybe in the next 20 years anymore because they consume so much energy for heating, cooling, ventilation. I think we have to come back to a more traditional kind of construction. I'm now here, I'm looking to an old castle here in my neighborhood. I'm in a hotel at the moment, a castle with climbing plants, yeah, with smaller windows, not with 80% of glass in front. I would say it's working, it performs better.
Mm-hmm. Yeah, I mean, climbers are a solution for extensive way to cool a building. And but there's also the question about the pots, the plant pots, if how the insulation is done. Maybe it's also for Erwin a question to protect them against overheating. We have the issue with the low temperature and the freezing, but in summer we also have the heat. So how do you design a pot or that it's not overheating? Yeah. We can't hear you, Erwin. No. Maybe we are coming back to the question later. I see another question. It's for Marco again. Do you have any data regarding the temperature and humidity condition inside the Hamburger Bunker in St. Pauli? No, we have an echo. I don't know.
Erwin, you have problems maybe with the microphone? Yeah, I'm just starting now with the measurements because this project was set into operation last July, and I implemented lots of sensors. But it's mainly, it's a question, the benefit for the environment is the evaporation of water. It's a water cycle. So how much from the incoming water is converted into evaporation? That's the main question for climate adaptation. And in my view, climate adaptation is mitigation at the same time, at least for the urban heat island effect. And therefore I concentrate on the water cycle. Yeah, so it's a large, I would say, lysimeter system, yeah, where I measure runoff, yeah, in the water level in the tank, and I measure in each floor the irrigation, and I measure the temperature to find out the potential evapotranspiration rate. And we try as well to harvest stormwater events, yeah, to reduce stormwater. That, I think that's the main topic at Bunker St. Pauli, and want to try to find out the effect like in Adlershof for the Institute of Physics. Always try, if you measure, to find out the complete water budget for your project. So you need to find out the evaporation rate.
Okay, I see. Peter has a lot of comments. I don't know if we have enough time for this exchange. Maybe you can exchange directly with him about all your thoughts. I don't know, Erwin, are you able to answer the question back about the overheating? Yes, now it's working.
Does it working? Okay. Well, the cooling is not separately seen from the isolation what we do in the winter period. I try to show this one image. 1 second. This one. So the isolation is of course mainly for the winter periods, not too much freezing than the ground. In the summer times, because of the water circulation, there is no in directly overheating in this size of pots. The size of pot is in this case, of course, a big solution. Gerti, who is our senior in these situations, he needed to go to the next appointment. And he asked, when you have certain technical questions to this project where he was mainly involved, just write us an email on Rataplan, and we will be happy to answer all of them. That is the service what we can do, because we are really a little bit short in time. That is our problem. It took a little bit longer now than we expected. Yeah.
Thank you very much for your reply.
Yeah.
Peter, you had a question, right? Ellie will reconnect now, so I will.
Not sure if it was more or less a comment or a few comments, and what I mean, I know Marco for quite a while, for a couple of years, and I'm following him very closely, and also what he has done in Adlershof. This is very important for us, because we use this data that Marco provides and to convince our clients very often, because actually the urban heat island, of course, everybody knows is a huge problem, but we have to consider the heat is also transmitted into the building, particularly if you have a lot of windows. And the example that Erwin shows, I know also Rosemarie Stengel, she has shown this recently as well, this green glass project. I think the protection of the windows is in the future will become very crucial to provide a shade in the summer, but that we use deciduous plants, means plants that leave their leaves or throw their leaves in the winter, so that we have in the winter sunlight coming in and harvest the heat from the sun, but in the summer that we have a shade. And this was one of my questions about in the first comment, was a little bit towards Marco, is, and maybe Erwin, you can answer this as well. The question for me is always, or that my client asked me, we are currently working on a huge hospital in Berlin as well, where we want to provide a shade. And they said, okay, we cannot have the green facade right in front of the windows. We have to do it as you did in one of your projects, Erwin, where you have this, let's say, 90-degree greening.
Yeah. I mean,
nobody can, so far, we don't have any experience, any data figures about the shading effect and how much sun protection we can provide. I mean, Marco has done this in Adlershof, but he has more or less a full cover. But when we do this 90-degree, because people want to still use the windows, particularly in a hospital, it's very important that people can look out of their window. But I think you together with Rosa Marie Stengel, you have some data figures about the shading effect and the cooling effect and the shading of the
cooling
windows.
effect, yes. So the BOKU done monitoring of this project. And there are results already. I think we can send it to you when you
I have
them.
some exchange with Rosa Marie already.
And of course, in this case, it worked out because it was a southwest facade, not a directly south-oriented one. So this to block out the sun in the summer from the side direction with trellises was in this case possible. In other cases, we would come up with different solutions. It is really depending on the orientation of the facade. That's why we started also in this case. The idea was from the beginning on that, okay, we will do something what goes more out of the facade and not in front of the facade. Because we had the idea that it could work out, but we needed to make these simulations and looking to the sun positions of different months, different timetables, to also recognize where the spots are, what we maybe not manage to block out, and how big they are. Because all of this is, of course, in the final calculation then. Important, you can say, source for heating in the inside.
And
for this
in particular for this project is this waterworks, you call this office building, where you had this trellis 90 degrees to the wall. On top there was no plants. You had another shading.
It is always combined. You have always you can see the mix between you have the trokes. And sometimes you have also horizontal shading above the windows. It is always, this is an architectural, you can say, choice to have.
So you didn't do any research on this project concerning the leaf coverage or the leaf density or whatsoever?
Oh, that not from our side, that's on the BOKU for us. Which plants we should use to have the right amount of coverage from the side. And also for the winter period, because we have evergreens there, so that there is also a certain amount of coverage in the winter period.
I think it would be very, very useful in the future, because I think this 90-degree shading with plants will become very, very important in the future. This kind of solution, because we cannot close the windows literally, but providing a shade and a cooling effect at the same time together with the plants, but with this 90-degree solution. But however, my client, particularly here at this hospital in Berlin, they asked for figures and data. Can we simulate how much heat we will reduce the heat through the windows and everything? I mean, Green Pass, I'm working with Green Pass as well. But sorry, currently we don't have any data for this solution, but I think that would be very interesting to get this.
Regarding data and figures, we just translated a German and Austrian summary of studies where we translated all the benefits of green buildings, also regarding green roofs, green walls, and vertical indoor greenery. You can find them on our EFB website. If you go under to articles, it's one of the last articles we published, and there you can find the different categories, different results of studies, and it's a growing document. We are now also collecting more and more data, or if there are like new projects like the Glasgrün, which is where the research was done by at the supermarket, we will implement them all So yeah, and if you see a very important study missing, please contact the EFB office in order to insert your studies.
Very important. Thank you very much for this, because we need more data to convince our clients, because we really, at this hospital, we will do an in-depth calculation. For example, they say, okay, if we reduce the temperature in this upper floor of 2 degrees at hot summer days, we will have less infections. People can get home earlier. They will heal quicker. This means they save a lot of money. But then we have to prove that we can reduce the temperature 2 degrees.
So it's a very useful publication for you. It's also available in German. Some of our member associations are also going to translate it in their national language. But you find it here on our website in English. And yeah, in order to convince your customers, to convince political decision makers. I hope it's a very useful document for you. And yeah, regarding the time, I also have a question regarding the maintenance of wisteria, which is used very often because it's such a lovely plant. But sometimes I don't really see it blooming very much. So the question is to Guy, if are there any species which are more blooming, or is it the maintenance which causes or can interrupt the blooming, or is it the years we have to wait until it's very yeah, is there an age of a wisteria where it starts to bloom, or yeah?
Yeah, you're right. The wisteria are notorious for taking a long time to come into bloom. So the golden rule is to buy one that's in flower, but of course that can be much more expensive than buying one that's not yet to flower. So that is one way around it. Otherwise, patience is required. You have to let the plant grow. Sometimes the plants are grafted, not always nowadays, but sometimes they're grafted, and the graft can take over, and that's more vigorous and may take longer to flower. So buy one that has got a good graft and rub out any suckers from it. And then, according to established garden law, the trick is to let them flower, then they grow all summer, then you shorten them back to a couple of buds, which by some mysterious process initiates more flower buds. And then they'll regrow a bit until leaf fall, and then you trim them back again in the winter, just so that the flowers are more obvious, really. And that is said to induce more flowers. It's not too bad if it's a small wisteria, ideally one that's grown as a standard, not a climber. But of course, when you've got a tall wisteria, you have to climb up the side of a building, then it becomes rather difficult to carry out. And in any case, you see a lot of wisteria go up into great big trees, and they flower away without any pruning at all. But if one is having difficulty, it's certainly a strategy that is worth trying if it's at all feasible.
Okay. Thank you. There's also another question about the main criteria for the combination for climbing plants, the phototropism, or the speed of growth, or the soil criteria, or the irrigation requirements. What's the main criteria for choosing the right climbing plant? Well, what are your thoughts? I mean, I would say it's always the which goal you have, which greening goal you have. But Erwin or Guy, Erwin, if you're planning a project, what's the main criteria you are using in order to choose the right climbing plant?
Well, we of course work together with a lot of experts, and we are very happy to get informed all the time, because every situation is always something new for us. It is it is not easy to standardize these things, because it depends, of course, on the building. It depends on regulations of even the fireproof topics, and so it is really not easy to answer that. It has, of course, aesthetical reasons too when we choose plants, but not in first point. I wouldn't say that that is the first goal what we have as an architectural point of view.
Mm-hmm.
It is
Yeah,
more depends. Yeah.
It's quite a vertical greening. It can become quite complex, but
Yeah.
it's depending on your client, what the greening goal is, and then you have regulations. Then you have the type of facade, or like the exposition of the facade. Then you have to choose if it's sunny or shady. Then
for example, this last project what I showed with the supermarket, where we used parametric design. The main idea there was to use it is not just the aesthetical point of view. We didn't know which type of plants will be grown there, no? And different plants needs also different distances of the pattern what you use. And so to be as flexible as fast in responding when we know which plant we have, we decided to make it in a parametric way. So even that, we try even to keep it as flexible as possible for as long time as it is needed. The construction of our structures to be as flexible as possible in the planning phase. Not to fix it too early, and then at the end you have maybe too dense patterns where the plants what was chosen are not growing well. So yeah.
Mm-hmm. Well, are there any more questions or comments from our speakers?
Yeah, maybe just to the topic of shading. I don't know, I wrote it here in the chat, but I don't know whether I just answered one person or you could read it. We are, of course, using the shading coefficient of Adlershof in other projects. Yeah, so it's part of the calculation for the summer protection, which is obligatory in Germany. So if you start to construct a building, you always need, first of all, to calculate the overall energy consumption for heating, cooling, and ventilation. Otherwise, you don't get any permit to construct. And there you can use the data from shading from climbing plants. So we have always the coefficient of the G value from Adlershof. And this we use for further projects. And now it depends on which type of simulation you are using. So whether you use the DIN 18599, so this is the constant calculation, or whether you use Energy Plus, so a dynamic simulation. A dynamic simulation is always much better. And with a dynamic simulation, you can integrate as well the long wave emission from conventional blinds compared to the green plants. And so therefore you can implement in the calculation as well a climbing plant. And we did it for the project in Hamburg, for example, and other projects. So I can send the data if you want.
Yeah,
And-
please send it to us, and then we can share it with the participants.
Mhm.
Yeah.
I
Mhm.
have a website where we published all these documents from the projects, yeah. But it's not linked outside, yeah, because the publications are related to journals, so I cannot publish everything just with a public link, yeah. But you may just distribute it for all people who attended today.
Yeah, we can provide that. Thank you. Yeah. Just to inform you about other topics we have already done. We always upload our webinars on our YouTube channel, where you can find from green roofs to green walls different topics. And our next webinar is about quality assurance through technical standards and fire regulations. Because in Austria we have a standard which just got translated for vertical green, which just got translated into English, which will be presented by Vera. And of course, fire regulations are always, fire testings are always something highly asked. We combine those topics, and if you want to exchange in person with people from the green roof and green facade sector, there's the Congress in Basel, in Zurich, so in Switzerland, in June. You can find more information on our website again. And at this point, I really want to thank you, our speakers today. So thank you very much, Marco. Thank you very much, Guy and Erwin, for your time and your great insights you gave us about your work. And also thank you very much for the support of Karlstahl in order to do what we do with our webinars, to share our knowledge of experts. And and if you have any questions, please don't hesitate and get in contact either via email or contact us on our social media platforms on LinkedIn or Facebook. And if you want to see more webinars, so subscribe to the YouTube channel. You will be informed when there are new webinars updated. And at this point, I wish you a very nice evening. And thank you very much again for your time. And and have a nice evening.
You have a nice Easter.
Yeah,
And
thanks
Happy
for
Easter, of course. Yes.
thanks for the invitation.
Enjoy the Easter holidays.
Happy
yes.
Easter to everyone. It was very inspiring.
Bye.